Hello guys, today we will deal with an example in which we will show that the given function is not differentiable at origin but its partial derivative, even though its partial derivative exists at that point. So here we have to prove that the given function, which is defined like square root of mod x into y, it is not differentiable at origin means 0, 0, but its partial derivative, that is fx at point 0 comma 0 and fy at point 0 comma 0, first order partial derivative, these both partial derivative exist, but even though the function is not differentiable. So first of all, we will find its first order partial derivative at the origin. So here we have this function fxy is equal to square root of mod x into y. Then we know that the first order partial derivative with respect to x is calculated by this formula, where we take limit s tends to 0 f h comma 0 minus f 0 comma 0 upon h. So now we will put the value of x is equal to h and value of y is equal to 0 in this given function. So we get here this is equal to limit s tends to 0 0 minus 0 upon h, and this is equal to 0. So this exists because the limit, this limit is finite and unique. So again we will find its first order partial derivative with respect to y. So for this we will take limit k tends to 0 f 0 comma 0 plus k, that is k, minus f 0 0 whole upon k. Now again in place of small x we will use 0 and small k we will use y. So it gives us again 0 minus 0 upon k. This is equal to 0. So this is also exist. So here we have checked that the given function is the first order, for given function the first order partial derivative at origin exists. Now we will check its differentiability. For differentiability, we will construct function del z minus dz upon dz, and this will be equal to, first of all we will find del z. Del z is calculated by a plus h minus b plus h. So del z minus dz is always equal to fa plus h b plus k minus fab minus fx a comma b into h plus fy a comma b into k, where h is del x and k is del y. Okay, so because a and b points are here 0 0, we have to check the limit at the origin. So here it becomes f h comma k minus f 0 comma 0 minus partial derivative at origin into h plus partial derivative at origin into k. Here h into k is square root of h into k mod minus f00 is 0, and again fx is 0, fy is 0, so all values is 0. So this gives us, this is equal to square root of hk mod. Now if this limit tends to 0 as h comma k tends to 0, sorry, first of all we will write it in the form of epsilon 1 into h plus epsilon 2 into k. This is equal to this one. Now from here we can compare it by if we take epsilon 2 is equal to 0 function, then epsilon 1 will be equal to, this will be equal to square root of mod h into k upon h. Now this is 0 function, so it always tends to 0 for all h and 2k. So it always goes to 0 as hk tends to 0, 0. But if this function is also tends to 0 as hk tends to 0, 0, then we say that the given function is differentiable at the origin. Okay. So for this we put in place of h is equal to r cos theta and k is equal to, we will use r sin theta. And when hk tends to 0, 0, that means in that case r must be tends to 0. So the limit of function at point hk tends to 0, 0, because epsilon 1 is function of h comma k. So in place of this we will use r tends to 0, and in place of h and k we will use these two coefficients, these two factors. So here it gives us r square sin theta into cos theta whole upon r sin theta. So from here, because this is square root of r square, so we can cancel out this by this one. So limit r tends to 0 is equal to square root of sin theta cos theta mod upon sin theta. So here we can see that this value does not depends on the value of r, that is depend on the value of theta. So for different value of theta it gives us different values. Suppose if we take here theta is equal to pi by 4, then sin pi by 4, cos pi by 4 and sin pi by 4 never tends to 0, because this will tend to 0 if at least this factor or this factor, that is sin theta is 0 or cos theta is 0. And we know that the sin theta and cos theta are will be 0, will be vanishing only for theta is equal to 0 and theta is equal to pi by 2. So only these two values of theta, the limit x comma h 0, 0 epsilon 1 tends to 0. Otherwise it does not tends to 0. So that means this limit does not exist. This limit does not exist, and which implies that the function is not differentiable at origin. This conclude that the given function fxy is equal to square root of mod x minus x into y is not differentiable at origin, even though its partial derivative exists at origin. Both exist, but so that means the differentiability of function of two variable does not depends on the value of on the behavior on the value of part